Hello everyone. Today I am going to discuss a new topic and very important topic concept, merger graph and merger table. In the previous lecture I have discussed about the k distinguishable and state equivalence. With the help of this concept I have just minimized a finite state machine. But what will happen, suppose we have a finite machine and some of the present state, or you can say next state is absent, and also look at this table. So where the next state is for this entry is E and next state is E and output is 0, but some of the entry, for example in B, the next state is missing, even the output is missing. So it may be next state is missing, it may be output is missing. So in this case, how can I reduce a machine, and that kind of machine is called incompletely specified machine. Incompletely specified machine. So the machine has not specified. So in reducing machine, we can think as a don't care condition, or we can think as a don't care entries, and that if I transform the incompletely specified machine into a completely specified one, such a specification may not be optimal, and then would drastically reduce our freedom in simplification of the machine. Or it means that if I want to reduce that kind of machine or incompletely specified machine where the next state somewhere is missing, where next output, or we can say output is missing. So according to this example we can say that, so what is the solution? So if there is a incompletely specified machine, therefore it is desirable to first to generate the entire set of compatibilities and then select the appropriate subset which will form a basis of state reduction and leading to minimal machine. But since set of the state is compatible if and only if, in our previous lecture I also discussed about that, if two states are compatible or two states are equivalent. So first it is sufficient to consider only a pair of state to use them to generate them the entire set. So means if a pair of set Si and Sj is compatible pair, then another compatible pair is referred to as implied pair. So merger table or merger graph serve as a measure tool to determine the set of all compatible compatibilities. Okay. So the purpose of merger graph is to find out the number of all set of compatibilities. So now the question is, what is merger graph? So from the definition we can say that, so the merger graph of n state machine. So now we know what is the purpose of merger graph. Actually we want to reduce a incompletely specified machine where sometimes output is missing, next state is missing. So in that type of machine, if I want to reduce, then first we have to find out the compatible pairs, and merger graph is initially do the same thing. So then we use the compatible status of this graph, or we can find out the compatible pairs, and after that we will use the compatibility graph. From there we can we will get the implied pair, and from this we can reduce our machine to a equivalent machine of a given input machine. So first step is, first we have to consider the merger graph, and then we have to draw the compatibility graph, and then from where we can get the ultimate implied pair, and we will ultimately reduce our machine. So what does mean the merger graph here? So merger graph of n state machine, it is an undirected graph defined has the following properties. First, it consists of n vertices, each of which corresponding to the state of n. So in this example, you can say, in this example, here how many states are there? 1, 2, 3, 4, 5. So 5 state. So we can draw. So each of the state is corresponding to a node of vertex of a graph, right? So we can write like this: A, and this is my another state, then you can write C, then you can write D, then E. So each of the vertex of a graph is corresponding to each of the state first, okay. Then two state Si and Sj, two state, if I compare A is a state, B is a state, so if I consider two state, will have a uninterrupted arc. I will discuss what does mean uninterrupted arc between them if their output as well as their next state does not conflict for their input, okay. And the third point is, I am coming in this point again, for each pair of state Si and Sj will have an interrupted arc. So we have a two kind of arc, one is interrupted arc, another is uninterrupted arc, right. And if their output does not conflict but have different state transformation for same input I, what does mean actually? And so these two, point 2 and point 3 are similar. One is undirected graph, uninterrupted arc, another is interrupted arc. But only one condition we have to remember, that there must be an arc if the output does not conflict. So last line is conflict for any input. In the previous lecture I have discussed, when two state sequence are same, output produce the same sequence of output and for the same input, so then we call it equivalent machine, right. Equivalent the state we call it, okay. Here if the output is not conflict, so that means if both state are equivalent, we can say that there is an arc, but the arc must be interrupted or uninterrupted, it depends on the next step. So this is the second condition, whether arc is interrupted or uninterrupted, so that will be depend on second condition, okay. And the fourth condition is, there will be no arc between Si and Sj if their output conflict. So if there is output conflict, so there is a no arc. So far we have discussed the number of state merged state graph means the number of state is equivalent to number of vertex, right. And about arc, I can tell you that if both state are compatible, that means their output don't conflict, then we can say there is an arc. But the condition is, if I check the next state, if the next state is different for both state, then there is a interrupted arc, right. Let us take an example. So first I am taking A and B. So here if I apply any of the input, for example it may be any of the input, for this input the output is 0 and here the output is don't care. So that means we can consider as a 0, and here the output is next state is don't care condition. So that means we can think any of the state, it may be A, it may be B, C, D, E, any of the state may be present here. So let us consider they are not conflict because both state are same. Then consider the for the input I2, here both output are same, because 0 here is not nothing, that means we can consider 0 also. Here there is a don't care condition, but here is a 0. So both output is same for the state A and B. According to our definition, if their output don't conflict for the same input sequence, then there must be arc. Now the second point is we have to remember whether it is an interrupted arc or uninterrupted arc. So let's consider. So E here is nothing, so we can consider any of the state, so no conflict here. The next state, here the change, here is B is the next state, here D is the next state, so there is a conflict of next state. Here is a B, C, and here is a B also. So here is also a conflict state. So both two states are not same, next state are not same. So what can I do? First we have to write a arc, because they are, the output are same, and since these two states B and D and B and C are making conflict to the so there is a interrupted arc between the A and B. So how can I write in this way? So later I will check whether the interrupted implied pair is hold or not. So first we have to write this one. So first let me write. So there is a arc, but there is a between B and D is one of the interrupted implied pair, and BC also. And later we will check that if any of the, if BD is hold, then AB is also hold. But any of the interrupt arc, for example, if BC is not hold, there is no arc between B and C, then this arc must be cross. So let me do that so we can get the idea. So second thing is, let me check. So first I have checked A and B. Now consider A and C. So there is no output change, both output are same. Here the output is changed, here output is same, so there is a no problem. But here both next state are same, but here the next state is different, here the same. So only BD is not compatible. So there is an arc between A and C, there is an arc between A and C, but this is implied pair, that is BD, right? And now consider A and D. Is there any arc? 0 0 0 0 0 1 1 we can consider, but BC B, okay, CE. So BC and CE we have a interrupted arc between A and D. So BC and CE. But there is a arc. Then consider A and E. A and E. So output is same, output same for input 2, and for I3 the output is also same. So output is same. Now consider E is C, next state is E, next state is C. Here B, 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 C. So BC. So only there is an arc, the arc must be interrupted, and it is BC and CE. So in between A and E, BC and CE, right? And now consider BC. So BC, whether they are compatible or not. So output is same, so there is a arc. So consider the next state. Here the next state only BC. So BC is compatible if BC is compatible. So it's a trivial solution. Right now I am just writing, but it is eliminate. Okay. So that is okay actually. Okay, no problem. Consider B and D. So here the output is same. Here 0, here don't care, and here also don't care, here also don't care. Here is 0, here is 1. So there is output is conflict. So there is a no arc between B and D. So there is no arc between B and D. Why? Because the output is conflict. Now consider B and E. So where output is don't care, here 0, don't care. Now check C and D. So output is same, here don't care 0 1. So here is the output is conflict between C and A, between C and B. Okay, so C and D, their output conflict, so there is a no arc between C and D according to our definition. Okay, now compare C and E. So here output is don't care, here 0, don't care 0 1. Here also output is conflict, so there is a no arc between C and E also. Now consider D and E. Here the output is 0 0, don't care 1 1. So there is a arc. Now consider the next state. Here the next state is C C. Here for input 3 the next state is B B. So there is no interrupt. So it is a uninterrupted arc between D and E. So let me draw a arc, uninterrupted arc. Now consider A B, whether A B compatible or not. So here A and B, BD, if BD and BC is compatible, then AB is compatible. So now consider BD. So there is no arc between B and D, and there is no arc between B and D, but there is an arc between B and C. But any of the pair is not compatible, then there is a no arc. So we should put a cross across this arc. So this arc is not possible, right? And BC is trivial. So if BC is compatible, then BC is hold. So it's a trivial solution. So it is okay. And now consider the next one, AC. AC is compatible if BD is compatible. So there is there any arc B and D? No, there is no arc between B and D. So BD is not compatible. So AC is also not compatible. Then compare A and E, A and D. If I compare, if BC is compatible, BC is compatible, that is okay. But CE is not compatible, right? C is, there is no arc, so it is no arc. So completely it will remove. Now consider AE. AE is compatible if BC and CE is compatible. BC is compatible, it's okay, but CE is not possible because there is no arc between C and E. So this arc is also not compatible. Okay. So now if I compare E and C, B and C, okay, C and D, there is no arc. Oh, so this is the ultimate solution. So here we got 2 arc and 5 vertices. Here the arc is ED is a uninterrupted arc and BC is also uninterrupted arc. And then we will check the compatibility status, or we can say implied pair. So in this example we see that we have to look for the polygon, but if the polygon is not present, so we cannot reduce further. So this is the merger graph. Let us try another example very quickly so that you can get the idea. So here is another example. Say how many states are there? 1 2 3 1 2 3 4 5 6. Here 6 state is there, and how many input? 4 input. So let me draw according to each of the state. I have to draw a arc. So let me I have to draw a vertex. So A, so B, C, D, then E, then F. Okay, I have already done it. Now compare A and B. So there is output 1 not 0, 0, don't care. So we can say there is an arc between A and B. And is there any conflict? Next state EC. So there is a conflict between, there is an arc between A and B, but CE is conflict. So that means it is a interrupted arc. Okay. So later we will see that whether this arc is possible or not in this graph. So now consider A and C, 1 1 0 0 0 0 0 0. So there is a arc, but the next checks the output and next state. So VF and DE. So AC is a arc AC, but we have a B, we have a BF. Okay. So there is a arc, but we have a BF and DE. So BF and DE. Okay. Later I will check it. Now AD 1101. So there is a conflict of output. So there is a no H between A and D. Now consider A and E 1100 1100. So there is a arc. Now check the next state. Here E, here A. So AE and here AE. So only, so AE is the arc, and also if compatible, if A is compatible. So it's a trivial solution. We can write it or you can ignore it. So you can write AE. So right now I am just for simplicity I am writing this one, but it is okay. Okay, we have seen in our earlier example. Now consider AF 1101. So there is a conflict in the output. So no arc between A and F. Now consider BC. BC. So BC is arc possible, and no interrupted. So it is uninterrupted arc between B and C. B and C is a uninterrupted arc. Okay. Now consider D and D. Don't care 1, don't care 0, 1. So there is a arc, but the state is B and D. So BD is also a uninterrupted arc, B and D. Okay. Now BE, don't care 1, 0, 0. So there is a arc, but there are next state is different for E, AC. So AC, there is a arc between B and E, there is a arc, but there is a only different is A and C. Okay. So there is a arc between these two, A and E, but AC is a implied pair. Okay. Now consider BF. B is complete. BF, don't care 1, don't care 1, 0, don't care. So there is a arc between B and F. Now check the next state. Next state, don't care C. So next state is also possible. So BF is uninterrupted arc, right? Okay. Now BF is complete. Now CD output is different. Here the output is different. So no arc. CE 1, don't care 0, don't care 0, 1. So there is a difference also, C and E. So CE is not possible. Now consider CF 1101. There is a conflict in output 0, 1. So CF is not possible. Now check DE. So there is no conflict. So DE is a uninterrupted arc, right? So we know that merger graph is a undirected graph, and DF, now check DF, don't care 1, 1, don't care 1, don't care. So DF is a arc is possible. Now check BC, if BC is possible. So DF is possible if BC is possible. So DE is possible if BC is possible. Okay, if there is an implied pair. Now check DF. Now check EF. Don't care 1, don't care 1, 1. So EF is possible, but here is a AE. So EF, but AE. Okay, AE. Now we have done. Now we have to check the compatibility. whether this arc is possible or not. So, now check first AB. A B, is there any arc? Yes, CE. C is present, CE. No, C is not present. So, AB is not possible, right. And now check AC. AC BF, BF is possible, BF, BF, BF is possible, that is okay. Now check DE, D is also possible. So, this is okay. Okay. So, ultimately this is okay. Now check AC, then AD is not, AE, AE is possible if A is possible. So, it is a trivial solution. So, A is okay. Now check AF, there is no arc, it is okay. Now complete, A is complete. Now consider BC is possible, BD, BD is also possible. Consider this one BE, BE is possible if AC is possible, AC is possible, yes. So, this is also okay. Now consider this one. So, DF, DF is possible if BC is possible, BC is possible. So, that is okay, no problem. Actually, we do not have to write it. So, first we have to write it, then we have to cross it or write sign. Now consider AE. So, AE is possible if EF is possible if AE is possible, AE is possible, right. So, this is also okay. So, this is the merger graph for the corresponding input table. Now, we have to find the compatibility pair, because our ultimate solution or purpose is to find out the compatible pair. Compatibility status. Now consider we have a AC, we have AC, okay, we have AD, AE, okay, and A is complete. Then we have BC. Always try to remember the first letter first. So, we never write CB, so it will make a mistake. So, always try to write BC, not CB, AE, not EA, okay. So, BC, BC is BC, then BD, BD, then BE, BE also possible, BE, BE, then BF, BF is also possible. So, BF, B is complete. Now consider C, C already I have written A, C B is already written, C E is not possible, C D is not possible, C F is not possible, C is complete. Okay, now consider D, D, D is D is DE is compatible pair. So, write DE and then DF also. So, DF also and EF also, right. So, that is the compatible status of this graph, compatible pair. So, from this we can also reduce, for you can know that B D, B C, B D, B E, B F. So, I can write like this B D E. So, B D E. So, we can write B D in a single step. Even if I write B and D, because after that, after finding the merger, draw the merger graph, we will looking for the compatible pair. So, where we will look for the polygon. So, is there any polygon is present or not, because merger graph display all the possible pair of state and they are implied pair, and since a pair of state is compatible only if the implied pair is. So, we must first to determine and then we will indeed a compatible, we will check. In order to say that, we will find the minimum set of compatibility to get the original machine, and we can use to basis of construction of minimal machine, we often use to show maximal compatibility, and for this we will go for the any complete polygon, so that they are not contained within any higher order complete polygon. Okay. So, we will that not contain any other compatible state. So, we will look for the polygon. So, here we have seen that BD and EF. So, BD EF also it form a complete polygon. So, we can reduce the number of compatible pair. So, AC, and we can write BE or you can write BDEF. So, let me write BDEF. So, BDEF we can write here, and from BDE we can write from here also. So, AE, BC, then BD, BE, BF, DE. Okay. From this we can write BDEF. Okay. BDEF, we can write BDEF. So, this is the minimum, or you can say minimal compatible pair. Okay. So, that is all about the merger graph. I hope this is clear to you, and next lecture I will cover the merger table, and also I will discuss about the compatibility graph and how do I get the implied pair to find out the minimum close covering, so that we can reduce the machine ultimately. I will discuss in my next lecture about the merger table and compatibility graph, and ultimately we will achieve our solution. Thank you very much.